Hello, this is Ricky from Data Mastery and welcome to this new video. In this video, we are going to talk about some of the theoretical part of open tables. We have been making videos on platforms like AWS, Snowflake, which are very technical and hands-on. We got some feedback to make videos on the theoretical part of some concepts so that people can understand the concepts better. And we can obviously make these videos using platforms like AWS, Snowflake, or even Databricks as well. We are going to introduce Databricks in the future videos. But before we actually start working on those platforms and working on the data engineering or AI, functions or tasks, it is good actually to have the theoretical understanding. Basically, understand the concept first, and then you can pick any tool. It doesn't matter if you're working on AWS or Azure, Snowflake, Databricks. These concepts are gonna remain similar. So when we make the video on specific platform, obviously we talk about the how things work on that specific platform. So the first video of that series where we're gonna explain the theoretical concepts with a very, you can say, common analogy or which is very easy to understand. The first topic as of today's video is open table formats. Now this is kind of, if you're working in the data engineering field or AI, this is something you probably heard about. But what exactly is open table, right? So what exactly open table format is? Now, if you go with more technical definition of this, you can say that open table format is something that is used to define a standard layout, metadata structure, and behavior so that other tools can connect to these tables in a similar fashion. So this is not something which is a proprietary to any organization or any company. So in simple terms, you can say that open table format is like a set of instructions that helps you to keep your data organized, know what changed and when that change happened, find things fast, and share your data. So it is kind of a set of instructions which are common for any of the client which is trying to connect with their open tables. So they will all understand this format. That's why it's called open. So the second thing is why it is called open. Well, because everyone understands it and it's not just specific to one company or one organization. So in a simpler terms, a set of instructions that all of the clients connecting with your tables can understand, the structure of your tables and schema and whatnot. And it also helps you to keep your data organized and know when things changed and how to find things faster. So this is a generic kind of definition of open table formats. Now let's take an example or analogy of a closet. Now you have a closet, which is obviously not just a pile of clothes, but if you have drawers and labels, and also a little notebook that tells you like where everything goes, like where you have put everything, when was some stuff was added or taken out, and if you changed anything. Now, if you have a closet which is full of clothes without any structure, that is kind of a common data lake, right? So you have a data lake, you have the data in there, but it's not structured. Structure means not a structured data, but a structure in a certain way within the data lake that when your clients are making the connection with your data lake, they should be able to understand about your data. So if a closet is just a pile of clothes, then it's like a data lake with bunch of data but without any kind of meaning or structure to that data. But when you organize your closet with drawers and labels and also make the note of when changes happens, that is what your open table format is. So this closet system with all these drawers, labels, and the notebook which takes all the notes, this is your open table format. So think in that way that your open table format is, this is where you put your data. like in the drawers, and you have the drawers with some labels, like this drawer contains my, my t-shirts or my shirts and my pants. And then you're making a note of when things being added to the closet or when things being taken out of the closet. So this is the analogy that helps you understand what exactly open table format is and how it works. Now there are different open table format types, I would say. So that's what we're going to talk about now a little bit. So like I said, imagine if your closet is full of clothes, then that is like a normal data lake. Everything is there, but it is so messy and hard to find what you need. Now then comes your open table format, and the first one is Apache Iceberg. Now consider Apache Iceberg as a closet with labeled drawers. So you have a drawers, and those drawers are labeled, labels like pants, shirts, winter clothes, summer clothes, and it even tells you when you added or removed something. So that little notebook that I explained earlier, so which is basically what Iceberg tracks. It takes a note that when things being added to your closet or your drawer, and when things being taken out. And for example, you can open the socks drawer and you find exactly what you want. So your socks drawer will have socks, like they won't have pants or shirts. So all this metadata and everything is being managed by Iceberg. So this is a kind of a common comparison that you can make when you try to understand what Apache Iceberg is. Think about closet with the labeled drawers. And you can also for the easy searching, or you can also say that look back and say what was in my closet last week. So this is what the time travel is. So it will take a look at that little notebook, and it will tell you, okay, on this particular date in my closet, there was these items which were present in my closet. So this is the notebook is something which tracks the metadata in technical terms, and that's what Iceberg keeps track of. And the next one is the Delta Lake format. Now imagine Delta Lake, something with a closet with a magic undo button. So if you, let's say, you put things in and take them out and even fix the mistakes. But in Apache Iceberg, well, we noticed that, okay, you can put things in, you can take things out, and it keeps track of everything, and that's fine. But what if you make a mistake? What if you put a shirt in the drawer where you're supposed to put the socks? Iceberg is not gonna fix that problem for you. So Iceberg will tell you, okay, you put a shirt in the socks drawer. It will make a note of that. But if you want to fix those mistakes, this is what the Delta Lake is gonna do for you. So you put a shirt in the wrong drawer. So imagine like you are pressing the undo button and it fixes things for you. So this is what Delta Lake is used for. So it is great if you are changing things often, and it is also good if you want to fix the mistakes that's being made during the adding data or something like that. Now the third one is Apache Hudi, which is a super fast closet helper. So what exactly it is. So imagine you are really busy and clothes are flying in fast. And so you are getting too many clothes that you want to fit in the closet. Your helper quickly throws them in the labeled baskets. So imagine you have like you did a laundry. There's so many clothes that you want to fit in the closet, and if you have a helper that will just help you to put the closet in the correct labeled basket, that's what Apache Hudi is. And once putting in the baskets, so they also organize into the right drawers. So it's basically when you're getting a lot of data, you want to organize it super fast. That's where you use Apache Hudi. So these are the common open table formats which we use. Iceberg and Delta Lake are something which are pretty common nowadays. If you're working on Snowflake or Databricks, you probably have heard about these two a lot. Most of the time, you create a table in the Delta table format, and then that's being consumed by Snowflake, or you create that in the Snowflake and being consumed by other clients. So this is a common scenario, a common practice right now, which is being followed in the industry. So when to use Iceberg? When you want to have your closet super tidy. So closet here means your data lake. and remembers everything, make a note of all the transactions, metadata. So the delta lake tables, when you want that the mistakes should be fixed easily, so that's where you want to leverage delta lake. And Apache Hudi is when you want things to happen super fast, when you have like a lot of data coming in and you want to arrange that data very, very quickly. So that's when you use Apache Hudi. So these are like the standard open table formats. And I just try to explain it in a very, very, the common language using this closet analogy. Hope it helps you to understand these concepts. Obviously, when you read about that more in the technical terms, you just take this analogy in your mind, then you'll be, it will help you to easily understand what these different formats do. So uh, I hope this helpful. And if you have any question about these formats, any technical question or whatsoever, please post that in the comments. In the upcoming videos, we will have some technical hands-on session like the videos that I usually make, based on Snowflake or AWS or even Databricks. So we will have some technical videos coming down the roads where we will be using these formats and consume the data or create the table, create the iceberg table in Snowflake and consume it somewhere else. So stay tuned for these videos. I really hope that this simple video helps you to understand these concepts. I'll be making similar theoretical videos with simple analogy so that the complex subjects or topics can be easily understood. And let me know, always looking forward to the feedback. If you want us to make any certain types of videos, we can do that as well. But that's all for this video. Hope you like it, and do subscribe to our channel if you haven't done that already, and hit that bell icon as well to get the notifications. Thanks for watching, and stay tuned for more videos.